Okay, the last set of problems that we're going to be dealing with in this chapter 3 deals with what we call optimization, which is another fancy word for maximum and minimum problems. So I'm going to do a couple of problems in our homework set, the odd number problems, and show you how you go about doing these problems. It's basically a culmination of everything we've learned in this chapter, and it's not too bad. I think you'll be fine with this, but we'll see. Problem number 5. We have two numbers that are multiplied together to give us 192. And we are told that the sum of the first number, which we're going to call x, and 3 times the second one, which we're going to call y, so that becomes 3y, so x plus 3y is the minimum. So we're going to designate that with a third variable, capital N. So it's going to look like this right here. And then the x, y equals 192. And the x plus 3y equals n. That is what we call our primary equation. That means whatever we're going to substitute with is going to go into that equation. And so as you can see here, I divided by x, and I'm going to get rid of my y in this equation here by replacing the y with 192 over x. Alright, so that's what this ugly spot looks like right here. Okay, now next thing is a little housekeeping. Multiply by 3, and get x plus 576 over x equals n. And then I'm going to rewrite that. Remember our little rewriting bit in chapter 2 that we did? Yeah, it's very important. So we're going to make that denominator x to the negative 1 power over there. It's a lot easier to derive that way. Speaking of deriving, that's exactly what we're going to do here. The derivation of x is 1. Derivation of this expression, this negative 1, comes in front of the 576, we get negative 576. Subtract 1 from the x gives me x to the negative 2. And then that is going to be our first derivative. And we're going to set that equal to 0 and solve for x. See what we get. Okay? And again, the reason why we're going to solve for x is because that is going to be our 0 point, our inflection point. So we're going to solve and see what that is. It's either going to be minimum or maximum at that point. If it's, and we'll talk about what that means when we get to that. Okay, but we do know that the slope at that point on this curve for that particular function is going to give us 0 because it's a horizontal slope. Alright, so next thing we're going to do is we're going to, like I said, solve for x. So I move that 1 over, and then I got rid of the negative signs on both sides. So that gave me 576 x to the negative 2 equals 1. Then divide by 576, which I did. Now at this point, there's one of two ways we could do the problem. If I want to get rid of the negative exponent, I multiply or take both sides by negative 1/2 power. I don't like fractions, I don't like negative exponents, so I just turned it around. This is not necessarily an important step to make. If you multiply both sides, or not multiply, but if you take both sides to the power of negative 1/2, everything is good. No matter how you do it, you should get 24 for your answer. So the question is that 24 a minimum or a maximum for that particular value in this function? So let's find out. That's where the second derivative test comes in. Concavity, is it up or down? So, and of course you could always graph that to see what it looks like, but this is better to do this. So I take the derivative of both sides. I take the derivative of this, that's 0. Negative 2 comes over, makes that a negative 2 there, times negative 576. And then subtract 1 from the x to the negative 3. Now you could have changed the signs of both, and that would be totally unexpected and acceptable. Regardless, you do end up with 1152 x to the negative 3. Now we're going to plug in the 24 for the x to the negative 3, and we get a value of 0.0833. That is greater than 0, so that is telling us that when we have the inflection point is starting to go up at that point, that means it's starting at the minimum and going up. So we are dealing with a minimum value. So all we have to do now is solve for y. So I take the original equation, x times y equals 192. Plug in the x with 24. Solve for y, I get 8. So the two numbers of question are 24 and 8. Really isn't that bad. It's a process that you need a little practice on because you've never done this before. But I think once you get into it, you find it's pretty basic. As long as we don't get too crazy with the calculus, right? All right. Next one is an interesting problem, number 19. You've got a farmer who has a fence along a river and is trying to minimize the amount of cost of his fencing, so he's doing a little calculus. So a smart person using calculus in this scenario, and it's a wonderful idea. So this is what the fencing is going to look like. It's a rectangle with a missing side. The river is the missing side, so we're just going to, the perimeter instead of being 2x plus 2y, now becomes just plain 2x plus y. That's our primary equation. And we use P for the primary equation. We're also told in this problem that the area is 180,000. So, since this is the primary equation, we're going to rewrite this so we can get rid of one of the variables. Again, we're going to get rid of y. Don't have to. Get rid of x. It still works out. But this is what I did because I had a scarring childhood memory involving the letter y, and I will never use y again in an equation like this. But it's not true, and I'm very disturbed I even said that. All right, so moving on. So the perimeter then becomes 2x plus what y is, goes right there, 180,000. Rewrite it, so we can derive it. Do x to negative 1 instead of over x. Divide the 2x, we get 2. Divide this, the negative 1 goes in front, make that negative. And then we have 180,000 x to the negative 2, because negative 1 minus 1 is negative 2. So we're going to solve for x. So we subtract 2, divide by 180,000, and rather than use the calculator, I just went ahead and simplified it to 1 over 90,000 is equal to x to the negative 2. Reciprocate that, get rid of that negative exponent. Again, you could have taken x to the negative 1/2. I'm sorry. You could have taken both sides to the negative 1/2 power to get rid of the negative 2 exponent. No problem. I just didn't do it. Square root of 90,000 is 300. So we need to find out if that is a minimum or maximum to make sure this is going to work. So, take the second derivative of this thing right here. As you can see, same thing. Now we're just going to derive it. This becomes 0. I should have put a 0 in front, but I didn't because I'm lazy. And then negative 2 goes in front of this negative 180,000, and then the exponent becomes 1 less than negative 2, which is negative 3. Divide both sides. I'm sorry, not divide. I'm just going to rewrite this so that now it's become x to the third. Did I have to do that? No. Actually, you could have left that like that. Just go ahead and plug in the 300. You get the same answer either way. But remember, we're trying to figure out, since that's a double prime, it's a double or a second derivative, we're trying to figure out if it's a minimum or a maximum value. If it's negative, it's maximum. If it's minimum, it's positive. If it's positive, it's minimum. And sure enough, we get a positive 0.0133. There we go. But it is a minimum. That's what we want. Yes. So, solve for x by plugging in or solve for y rather by plugging the x to 300. Divide by 300. Y equals 600. And that means that our dimensions are 300 by 600. Now, I know I did a lot of talking through that, but the mathematics is pretty easily laid out. Of course, we'll have probably a couple of challenging problems, but I think most of you are ready for this. You guys have grown a lot in this class, becoming much better mathematicians than when you walked through my door. So continue the progress. Don't get intimidated by words. I know some of you get scared of words. Unlike Roxanne, the movie Roxanne, the guy thought he was afraid of words, but he said worms, and that was another failure. Words. Don't be afraid of words. All right? Your assignment. Pages 243 to 24. Those 4 problems. Have fun.